Today we're going to dive into factoring. This is my favorite algebra topic. Factors, factors, factors. Let's talk about first divisibility. If you have the number 10, its factors are 1 and 10 and 2 and 5, meaning 10 is divisible by 1, 2, 5, and 10. And that's what it means to be divisible, meaning you can divide it and you don't get a fraction as a result. You get an integer. So let's talk about some of the tricks of divisibility. All right, what kind of numbers are divisible by 2? Well, all even numbers are divisible by 2. So if it's an even number, then it's divisible by 2. Divisible by 3. This one has a cool trick to it. The sum of the digits must be divisible by 3. So is 378 divisible by 3? 378 has 3 digits here, a 3, a 7, and an 8. And to test divisibility by 3, the sum of these digits must be a number that is divisible by 3. So 3 plus 7 plus 8, that is 18. Now, is 18 divisible by 3? Yeah, 18 divided by 3 is 6. So if the sum of the digits is divisible by 3, then the number itself, 378, is divisible by 3. To be divisible by 4, it must be even, and the last 2 digits have to be a number that is also divisible by 4. So this is only going to be helpful for 3-digit numbers, okay? Otherwise, if it's an even number, it could be divisible by 4, but you're still going to have to check. But if you do have a 3-digit number, such as 212, is 212 divisible by 4? Well, we would look at the last 2 digits. And we're not going to add them like we did for 3. We're just going to write down that number. That number is 12. And now we see, is 12 divisible by 4? Yes, it is. And if 12 is divisible by 4, then 212 is also divisible by 4. To be divisible by 5, the number must end in 0 or 5. To be divisible by 6, the number must be even, so you must be able to divide it by 2, and it must be divisible by 3. If it's divisible by both 2 and 3, then it will be divisible by 6. Divisible by 7, for this one, you're just going to have to test it out. There happens to be a rule, but it's way more confusing than testing it. Divisible by 8. Well, it's definitely going to have to be an even number, but not all even numbers will be divisible by 8. So for this one, you'll also need to test it out. Divisible by 9. This one is very similar to 3, except the sum of the digits must be divisible by 9. And to be divisible by 10, your number must end in 0. Let's take a look at factors. So our first number is 24. I like to go in numerical order, starting with 1, so that I know I do not miss any, okay? Maybe you don't have all the factors memorized and you don't want to miss any. So first I will write 1. 1 times what is 24? 24. So 1 and 24 are factors of 24. Then I'm going to try 2. 2 goes into 24 12 times. 3 goes into 24 8 times. 4, 6, 5. Oh wait, this number does not end in a 5 or a 0, so I know 5 doesn't go in. So the next number I would test would be 6. But wait, 6 is already there. That's how I know I'm done, and that's why I like to write them in numerical order. What are the factors of 64? Starting with 1. 1 and 64. 2 and 32. 3. Does 3 go into 64? Well, let's test it. 64 has 2 digits, 6 and 4. And to be divisible by 3, the sum of those digits must be a number that is also divisible by 3. So is 10 divisible by 3? No, it's not. So neither is 64. Let's try 4. For 4, the last 2 digits need to be divisible by 4. Well, okay, that's the whole number. So 64. Is 64 divisible by 4? Yes, it is, and that is 16. What about 5? Nope, this does not end in a 0 or a 5. It ends in a 4. So 64 is not divisible by 5. What about 6? Remember, in order to be divisible by 6, 2 and 3 must also be factors. But 3 is not a factor, so 6 cannot be a factor. 7. Now I looked at the numbers I know 7 goes into, and 64 is not one of them. It's also helpful to know your multiplication table. What about 8? Oh, hey, I know 8 goes into 64. 8 times 8 is 64. So what about 9? Oh, wait. 8 is the number listed here. 9 is larger than 8. But all the numbers larger than 8 that are factors are listed here. So we can stop. The factors of 50, 1 and 50, 2 and 25, 3, is 50 divisible by 3? Test it out. 5 plus 0 is 5, and is 5 divisible by 3? No, that's going to give me a fraction. So then no, 50 is not divisible by 3. Let's try 4. 4 goes into 5 one time. That gives me 4. 4 goes into 10? No, not evenly. So 4 is not a factor of 50 either. What about 5? Hey, yes, 5 is a factor if the number ends in 0 or 5. So that is a factor, and that would be 10. What about 6? Well, 3 is not a factor, so 6 cannot be either. And 7 goes into 49. 7 doesn't go into 50. 8, I don't think 8 goes into 50. 8 times 7 is 56, so no, 8's not going to go into 50. 9, does the sum of the digits divide 9? No, so 9 does not go in. 10, 10's already listed, therefore I am done. And real quick, I want to talk about prime numbers. A prime number is a whole number greater than 1 that has no other factors than 1 and itself. So let's list the prime numbers between 1 and 20. Well, is 1 a prime number? A whole number greater than 1. Okay, so then 1 cannot be 1. 2. Does 2 have any factors other than 1 times 2? Nope. Okay. What about 3? 3 is just 3 times 1. What about 4? Oh, wait. 4 is 1 times 4 and 2 times 2. So 4 will not work. What about 5? 5 is just 1 times 5. What about 6? No, 2 goes into 6. In fact, no other even numbers will work. 2 is the only even prime number. 7, is 9 a prime number? No, because 3 goes into 9. 11, yeah, 11 is just 11 times 1. 13 is 13 times 1. 15 is, 5 times 3. 17, okay, 17 is just 17 times 1. And I believe 19 is also a prime number between 1 and 20. So these would be the prime numbers between 1 and 20. Now, why does that matter at all? Prime numbers are essential to RSA cryptography, which is data encryption. What? Data encryption happens when you shop online, when you send messages, whether in a messaging app like WhatsApp or in social media DMs, in order to keep your information just to you and not spread around, so people can't get your messages, get your credit card information from online shopping. All of this encryption involves really, really, really huge prime numbers that have 300 or more digits. Okay, those are massive numbers, but prime numbers are essential to keeping your messages safe, to keeping your credit card info from getting stolen, all that when you are online. Like I mentioned before, you should have this multiplication chart handy, and even better if it's in your brain, because then it's real accessible. Something that we're going to be talking about a lot this week is the greatest common factor, also known as the GCF. And that's the biggest number that goes into a selection of numbers that is given to you. For example, we have 8, 64, and 16. The factors of 8 are 1 and 8, 2 and 4. The factors of 64 we already did. And the factors of 16 are 1 and 16, 2 and 8, 4 and 4. So the greatest common factor, the GCF of 8, 64, and 16 is going to be the largest number that is a factor of all three numbers. Well, I can see that 2 is a factor of all three numbers, but is it the biggest one? Nope, 4 is a bigger one. What about 8? 8 goes into 8, 8 goes into 64, 8 goes into 16. Oh my goodness! So what is the GCF here? The GCF of 8, 64, and 16 is 8. That's the largest number that is a factor of all three of these. What about when we have variables? Well, x is just 1 times x. X squared is x times x. And x cubed is x times x times x. There are 3 of them being multiplied by themselves here. There are 2 being multiplied here. And there's only 1 being multiplied here. So the GCF, the greatest common factor, would just be x. Because the number of x's these have in common is each of them have x to the 1 as a factor. What's the GCF of x squared, x cubed, and x to the 4th? Well, x squared expands to be x times x. X cubed is x times x times x. X to the 4th is x times x times x times x. So what is the most amount of x's that they have in common? Each of them is made up of at least x times x. So the GCF here would be x times x, which we know is x squared. X squared would be the GCF of x squared, x cubed, and x to the 4th. Find the length and width. The width must be the greatest common factor of the area. All right, we have polynomials here, so just know that if x is in common with each of the terms in your area, then that will need to be a part of your GCF. The area is made up of 3 terms: a positive 2x squared, a positive 8x, and a negative 4. Let's check if there are any x's in common. There's an x squared, there's an x, and that third term does not have an x. So do all 3 terms share an x? No. So x will not be part of your GCF, your greatest common factor. So now we're going to look at those numbers, 2, 8, and 4. What are the factors? The factors of 2 are 1 and 2. The factors of 8 are 1 and 8, 2 and 4. And the factors of 4 are 1 and 4, 2 and 2. What's the greatest number that goes into all 3 of those? Well, that is just 2. So 2 is our GCF. Is there an x as a part of our GCF? No, because not all 3 terms have an x attached. All right, we know the width now. Can you find the length? Remember, when you're factoring, that means you're dividing. So let's divide each term in the area by our width to find our length. 2x squared divided by 2 is x squared. Positive 8x divided by 2 is positive 4x. Negative 4 divided by 2 is negative 2. What are we going to do? We're going to check it, which you must do in all your homeworks, in all your checkpoints. You are required to check. 2 times x squared, that is 2x squared. 2 times 4x, that is 8 with an x attached. And 2 times negative 2 is negative 4. So we did get the correct length. The length would be x squared plus 4x minus 2, and the width would be 2. In our second example, we have 18x cubed, positive 12x squared, negative 6x. First, I'm going to look at the x's. Do we have an x in common with all 3 terms? We have x times x times x. This term has x times x, and this term has x attached. What is the GCF of x, x squared, and x cubed? That was x, because you have x to the 1 in common with all of them. So x must be a part of my width. I want to take out an x because all 3 of them have an x. What about the numbers? The factors of 18 are 1 times 18, 2 times 9, and 3 times 6. The factors of 12, 1 and 12, 2 and 6, 3 and 4. The factors of 6, 1 and 6, 2 and 3. So what is the GCF? I see 3 goes into all 3 of these. Is there a larger number that goes into all 3 of these? Yes, 6. 6 goes into all 3 of these. Okay, so 6 must be the number part of the term that makes up our width. 6x. Let's find the length. Now, some of us prefer to think about multiplication rather than division, so in order to do that, I would say 6x times what number is going to give me 18x cubed? Well, x times what would give me that x cubed? X needs to be multiplied by x times x in order to get x times x times x. So it must be x squared, right? If you multiply x squared times x, then you would have 3 of them being multiplied by themselves. And 6 times 3 gives me 18. Let's try the next one. 6x times what gives me 12x squared? Well, x times what gives me x squared? There definitely needs to be an x in this term, and there needs to be a 2 because 2 times 6 gives me 12. And that would be positive because positive 6 times positive 2 gives me positive 12. Now 6x times what gives me negative 6x? That one's a little bit easier, I think. How do you get negative 6x? You multiply by negative 1. So 6x times negative 1 gives me negative 6x. It is time to check, and you must do this every time. 6x times 3x squared. 18 times x times x times x, so that would be 18x cubed. 6x times 2x would be 12. And there's x times x, so that is x squared. 6x times negative 1 is negative 6x. And that's our area. So the width of this rectangle should be 6x, which is our GCF, and the length is 3x squared plus 2x minus 1. What about this one? Remember, your width must be the GCF. Let's look at the x's. I have x cubed, x squared, and x. The most x's that they each have in common would be just x to the 1. Just x. So I've covered the x's. Now let's look at the numbers. 81, 27, and 36. The factors of 81 are 1 and 81. Does 2 go into 81? No, because 81 is not an even number. What about 3? Well, 3 goes into 81 if the sum of its digits is a number that 3 goes into. 8 plus 1 is 9. Does 3 go into 9? Yes, it does. Then we know 3 goes into 81. 81 divided by 3, there are 2 3s in 8, so that would be 6. 3 into 21 is 7. So 3 times 27 gives me 81. What about 4? Well, again, it's not even, so 4 won't go in. What about 5? It doesn't end in a 0 or a 5, so 5 doesn't go in. What about 6? Again, it has to be even. What about 7? I know what 7 goes into. I know the times tables for 7, at least up until, 7 times 12. And 7 doesn't go into 81. What about 8? It's not an even number. And what about 9? Yes, 9 times 9 is 81. Once you've reached that where they are the same number and you've gone in numerical order, then you're done. 1 times 27 gives me 27. Does 2 go into 27? Nope, it is not an even number. Does 3 go into 27? Yes, I remember that. That's 3 times 9. 4? No. 5? No. 6? No. 7? No. 8? No. 9. Okay, we're done. And 36 would be 1 and 36. Ooh, 2 goes into 36. 2 goes in 18 times. And 3, does 3 go into 36? 3 plus 6 is 9. Oh yes, 3 goes into 36, and that would be 12 if you remember your 12s times tables. 4. Does 4 go into 36? Yes, 4 times 9 is 36. 5, no, this does not end in a 0 or a 5. 6, yeah, 6 times 6. Oh, and we're done since we went in numerical order. So what is the GCF? What is the greatest of the common factors? I see that 3 is a common factor. Is it the greatest one? Ooh, 9 is a common factor. Is 9 the greatest one? I think it is. I think we have a winner. Our GCF, the number portion of our GCF, should be 9. Let's find our length. The terms in my area are 81x cubed, 27x squared, and negative 36x. Each of these terms needs to be divided by our GCF, which in this case is 9x. 81 divided by 9 is 9. X cubed divided by x. X cubed divided by x is the same as x times x times x divided by x. X over x is 1, so you are left with x times x, which is x squared. So that should be x squared. 27x squared divided by 9x. 27 divided by 9 is 3. That is positive. And x squared divided by x, that would be an x times x divided by an x. So you're left with x to the 1. Negative 36x divided by 9x. Negative 4. The x's reduced to 1. Let's check. Don't forget to check your work. 9x times 9x squared, that is 81 times x times x times x, that is x cubed. 9x times positive 3x is positive 27 x times x, which is x squared. And 9x times negative 4 is negative 36 with an x attached. Yes, that is our area. And remember that the greatest common factor, or GCF, is the largest factor that all the terms share.